Hello. Hi, this is Samant. So the topic that I am going to discuss today is trigonometric ratios. Okay. So particularly in trigonometric ratios, the concept that is very important to know or to discuss is the concept of trigonometric identities. Okay. So let me list down all the trigonometric identities in this chapter, which is the first trigonometric identity is sine square theta plus cos square theta equal to 1. Okay. And the second trigonometric identity is secant square theta minus tan square theta equal to 1. And coming to the third trigonometric identity, which is cosecant square theta minus cot square theta equal to 1. Okay, so these are the three basic trigonometric identities what we have in this chapter. Okay, so these are the basic three trigonometric identities. Now let us see how these trigonometric identities have been derived. Okay, so basically these trigonometric identities have been derived from the Pythagoras theorem. So what is Pythagoras theorem? What is Pythagoras theorem? Yeah. The Pythagoras theorem is a relation between the sides of a right angle triangle. Okay. How the relation between the sides of a right angle triangle will be means the hypotenuse side. So before that, let me draw the right angle triangle, and let us assume in the right angle triangle, the right angle is at B. When right angle is at B, so the hypotenuse length, which is the highest side of the triangle, nothing but the side which is opposite to the 90 degrees. This is the hypotenuse side. Hypotenuse side. And remaining sides are named based on the location of the theta. Let us assume the location of the theta at A. Okay. When theta is at A, then BC will be opposite side. BC is called as opposite side because as it is lying opposite to the angle theta, that BC side is called as opposite. Now the adjacent side is the side which is it's immediately adjacent to the theta. Okay. Now from the right angle, for any right angle triangle, the relation between all the sides, which is nothing but hypotenuse square equals to adjacent square plus opposite square. Adjacent square plus opposite side square. So this is the Pythagoras theorem. Okay. So now from this Pythagoras theorem, in three different scenarios, we will try to divide with the one side. We'll divide with one side after the other side with the square of it. Okay. So when I divide the entire equation 1 with the side hypotenuse square, okay. So what do I get now? If the entire equation, if I divide with the side hypotenuse square, then so hypotenuse square divided with hypotenuse square equals to adjacent square divided by hypotenuse square plus opposite square divided with hypotenuse square. Okay. So let us see what happens, what kind of result we will derive. Okay. So in the see the LHS side, the hypotenuse square will get divided exactly. We can cancel them, both of them. And now coming to the next part, you will get 1 equal, when after dividing, you will be getting 1 equals to adjacent square divided by opposite square, adjacent square divided by hypotenuse square plus opposite side square divided with hypotenuse square. Okay. So now after this, I can take square common to adjacent side and hypotenuse side. So which will be adjacent divided with hypotenuse whole square plus opposite divided with hypotenuse whole square. And you know the trigonometric ratio for adjacent divided with hypotenuse is what? It is cos theta, right? So cos theta whole square plus sin theta whole square. Therefore, you got when the Pythagoras theorem is being, the entire Pythagoras theorem equation has been divided with hypotenuse square on both sides. Here we are getting a result which is cos square theta plus sine square theta equal to 1. So this is the first trigonometric identity that has been derived in this way. Okay, now we'll try with dividing with one more side square. Okay, now let us divide the equation 1, which is, what is it? Let me write the equation 1 once again. So which is hypotenuse square equals to adjacent square plus opposite square. Earlier I have divided the entire equation with hypotenuse square, right? Now let us divide the entire this equation with adjacent square. I'm just dividing the entire equation with adjacent square. Okay, so here when I divide, I'll get hypotenuse whole square divided with adjacent square equals to adjacent square divided with the same adjacent square again plus opposite square divided with again adjacent square. So this is what. So okay, now if I take the square commonly, if I write for hypotenuse and adjacent, then I do get hypotenuse divided by adjacent whole square, which is equals to the adjacent square, and the adjacent square will get divided exactly and they can be cancelled, and you will get 1 plus opposite by adjacent square, which is opposite. You can write it as opposite by adjacent whole square. Okay, and the trigonometric ratio which is defined for hypotenuse divided by adjacent, which is secant theta, right? Secant theta. So simply it can be written as secant theta whole square. Okay, secant theta, and the square is already there, so secant theta whole square equals to 1 plus, and opposite divided by adjacent. What about adjacent? Opposite divided by adjacent, the trigonometric ratio which is defined for opposite divided by adjacent is tan theta. So tan theta whole square. Okay, so simply therefore it can be written as secant square theta equals to 1 plus tan square theta. This also can be written secant square theta minus tan square theta equals to 1. So okay, now let us, now this time in the case 3 we will divide the equation 1 with opposite square now. Okay, so let me write the Pythagoras theorem once again. Hypotenuse square equals to opposite square plus adjacent square, and let us divide the entire equation now with opposite square. When I divide the entire equation with opposite square, then I do get hypotenuse whole square divided with opposite whole square equals to opposite whole square divided with again opposite square plus adjacent square upon opposite square. Okay, so now just see hypotenuse whole square divided by opposite square. You can write this thing, you can write this ratio as hypotenuse divided by opposite, hypotenuse divided with opposite whole square, and this is equals to again opposite square will get cancelled. It will be 1 plus adjacent divided by opposite whole square. Okay, and hypotenuse divided by opposite, the trigonometric ratio which is defined for the ratio hypotenuse divided with opposite, which is cosecant theta, right? Cosec theta. So cosec theta whole square equals to 1 plus adjacent upon opposite. The trigonometric ratio which is defined for adjacent divided by opposite, it's cot theta whole square. Okay, now simply it can be written as cosecant square theta equal to 1 plus cot square theta. Okay, now, and this can be written as cosecant square theta minus cot square theta equal to 1. So therefore, this is the trigonometric identity. This is a trigonometric identity number 3. So here are the 3 trigonometric identities which are derived in this way. Okay, one you have to divide one. One trigonometric identity you will get when you divide the Pythagoras theorem with hypotenuse square, and one identity has been derived when you divide the entire Pythagoras theorem with adjacent square, and the other one when you divide with opposite square. So this is the topic for the trigonometric identities. Thank you.